Our next speaker for the day, our final speaker as well, is Varun Kher. He completed his master's in wildlife science from the Wildlife Institute of India. He has previously worked in semi-arid and arid grassland habitats to study various amphibians and avifauna. The title of his talk is Conservation of the Great Indian Bustard Using Telemetry. Over on to you, Varun. Thank you.
Hello everyone, I am Varun from Wildlife Institute of India's Bustard Recovery Program, and today I'll be talking about how telemetry has helped us in conservation of the Great Indian Bustard in the Thar landscape. As most of you are well aware, the Great Indian Bustard is amongst the most threatened bird species in the world and has declined precipitously in the last many years. It was once widespread throughout India's semi-arid countryside, but is now restricted to arid areas of Rajasthan, Gujarat, Karnataka, and Maharashtra. Its largest viable population of around 100 to 150 birds currently resides in the Jaisalmer district of Rajasthan, and I'll be talking about some of the tagged birds that are giving us crucial insights to conservation of this population. The historical decline of the species can be mainly attributed to human-induced mortality of adult birds, first due to hunting and now due to collision with power lines. It is estimated that around 10 to 15 Great Indian bustards die each year due to collision with power lines, and this is a big number for any species, particularly a critically endangered one. At the same time, GIB habitats, that is open grasslands and savannas, are declining rapidly, mainly due to conversion to industrial and agricultural land uses, fueled by the colonial policy of identifying these areas as wastelands. The entire thing is made worse by the biological handicap of life history that the bustards are blessed with. Bustards are poor breeders and recruitment in the wild is generally low. Thus, the stability of the population is contingent on survival of adult birds, and human-induced adult mortality can have a severe impact on their population persistence. To illustrate, look at the example here. Given no human-induced deaths, the population is expected to be stable, but just 2 human-induced deaths every year can lead to a big population decline. Given all these challenges, a Bustard Task Force was set up in 2010 and its recommendations were widely adopted as Bustard recovery plans. But implementing these recommendations, particularly these 3, required greater knowledge of the species, which could only be gathered through application of wildlife telemetry. Thus, the Wildlife Institute of India started tagging Great Indian Bustards from 2014. Between 2014 and 2019, 3 birds were tagged in Gujarat and Maharashtra by Dr. Jhala, Dr. Datta, and Dr. Bilal, respectively. But these populations had by then reduced to very low numbers, and it was essentially to study the largest population that was left in Rajasthan. Thus, a telemetry program for the population in Thar was started in 2019, and subsequently 7 birds were tagged, 5 in the Desert National Park Wildlife Sanctuary and 2 in the areas around Pokhran. These birds were caught using customized noose traps and then fitted with GPS GSM backpack transmitters using elastic harnesses. The weight of the tag was around 50 grams, which is less than 1% of the body weight of the species. Apart from the remote data that the tags were continuously collecting, we did a lot of follow-up surveys and ground tracking of the birds to understand various aspects of behavior and life history. Additionally, points used by the birds were sampled for vegetation and insects. This gave us a holistic understanding on the species of the species and on some important demographic parameters that were of interest for conservation management. So, coming to how this helped in planning conservation for the species, let's look at what we knew before starting the telemetry program. First, we knew that the bird is found in 2 clusters. To the left is the Desert National Park Wildlife Sanctuary, and to the right is the broad Pokhran area. We also knew from the tagged birds in Gujarat and Maharashtra that bustards are very large-ranging species and can cover the distance between these 2 areas very easily. We also knew that they need inviolate grasslands for breeding, but can use the overall agropastoral countryside during the non-breeding season. In Rajasthan, it was known that the birds disperse, but where do they go was something of a mystery. There were even suggestions by many scientists working in the landscape that the birds migrate to Pakistan, where they are hunted in large numbers, and that contributes to the decline of the species. Well, telemetry was the best solution to answer some of these questions, and what we found is presented here. So we could kind of ratify that the bird is indeed very wide ranging and has home ranges quite an excess of 100 square kilometers, which is quite large for a bird. We also saw that while it is using these enclosures or inviolate grasslands maintained by the forest department, it is also using some areas, agropastoral areas beyond these enclosures. Looking deeper at the data, we found that the species of the bird is very different in the breeding season as compared to the non-breeding season. In the breeding season, it is restricted to these old growth grasslands managed by the forest department, while in the non-breeding season, it uses the entire landscape quite widely, and even the non-protected areas surrounding these enclosures. We could again confirm that these breeding areas are indeed very critical for persistence of population and mainly for breeding of the species. We also saw that some newly created recovery, some new vegetation recovery through these enclosures was also helping the species, as some of these new enclosures are also used quite heavily by our tag birds. Let me illustrate all these points using this animation. To the left is movement data from the breeding season, and to the right is the data from the non-breeding season. This is end of July, start of August. As the breeding season is setting in, you can see that the birds are slowly restricting themselves to these enclosure patches, mainly the old growth grassland area in the middle, that is called Sudashiri. You can see that the activity during the core breeding season was entirely restricted to this area, and as the breeding season wore off, the birds moved out. Now, let's look at what happens during the non-breeding season. This starts roughly in November and goes on till February. And as you can see, the birds are moving in the entire landscape and even outside the enclosures. So broadly, we can summarize that during the breeding season, the birds use these protected areas very intensively, and during the non-breeding season, they move out and use the entire agropastoral landscape. Similarly, we didn't know much about the breeding biology of the species before the telemetry exercise was started. The earlier assumption was that females lay only one egg in a season and rarely nest again if a clutch is unsuccessful. This also sparked very genuine fears that the conservation breeding program that was started for the species will drive the bird to extinction in the wild. But we found that while most other information like incubation period, parental care, and breeding season was found through telemetry was congruent with direct observations, the part about fecundity wasn't. Our tag bird showed that females nest almost certainly and can lay up to 5 clutches if the preceding ones are unsuccessful. On the same lines, we saw that some of our tag birds whose eggs were collected for the captive breeding program relayed in the wild and successfully raised their chicks. For example, this is our tag bird 5949, whose first egg in the season was collected, named Corona in captivity because it was born during the first lockdown. And the bird relayed and then successfully raised a female chick in the wild. Coming to demographics, our dummy experiments and direct observations had shown that nest predation in GIV breeding areas is remarkably high, and chick survival was also expected to be very low given the erratic distribution of resources in this landscape. This, we thought, would lead to a very low recruitment rate in the wild. However, our telemetry studies gave us a much more nuanced perspective. First, as mentioned earlier, we found that the probability of a female nesting is very high, almost 100%. Let's, for the sake of explanation, consider that this square is a egg laid by a female, and each of these squares represent a 1% probability of a particular thing happening to the egg. These are 100 squares in this box. we found that not all bustard eggs are fertile, and about 40% of them are infertile. Thus, for any given egg, there is only 60% chance that it is fertile. On top of that, nest predation was estimated at 50%. So essentially, only 5 out of 10 eggs laid every year uh, will survive. Thus, taking both fertility and hatching success together, the probability of a wild egg hatching is quite low, around 25%. Uh, but this is offset by the high probability of a female renesting. Thus, if you look at these squares will add up given that the bird is renesting, and you have a fair probability of a wild egg hatching. But but the situation is complicated by the rainfall in this landscape, which is quite erratic. We found that in good rainfall years, the birds renested up to 4 or 5 times, but during bad rainfall, the degree of renesting reduced drastically. Similarly, the probability of chick survival was dependent on rainfall and was much lower during the bad rainfall years. Cumulatively, the recruitment in the wild was seen to range from very low to very high depending on the rainfall in that year. Apart from understanding ecology of the species, the telemetry data has also helped us in identifying and mitigating threats. 2 of the 3 birds that were tagged in Gujarat and Maharashtra died due to pollen collisions and showed us the magnitude of this threat. Our tag birds in Jaisalmer frequently cross power lines and are under a constant threat of collisions. Data from the telemetry exercise helped us refine and validate areas marked for power line mitigation, and the matter is currently in the Supreme Court under a case regarding power line mitigation. And the way forward, we currently use the telemetry data as a feedback loop for our conservation decisions. We hope to expand the scope of this tool further by tagging more birds, mainly males, and birds from other areas, mainly Pokhran and the area surrounding it. We plan to integrate data from other sensors with the GPS data that we get through our tags. We plan to use accelerometers and weather stations to correlate GPS data with them. We also hope to look at behavioral and decision-making related questions in the species. A habitat use study is currently ongoing, and most of the monitoring that I spoke about in this talk is expected to continue in the long run. As I mentioned earlier, my presentation today was on behalf of the entire field team of WI's Bustard Recovery Program. The team is led by Dr. Datta, who is a faculty at the Wildlife Institute, and mentored by Dr. Jhala from WI. Dr. Tushna, Mr. Bin, and Dr. Rathod keep our field efforts together with their experience. And my colleagues, Mohib, Devs, Saurav, Vishal, Indro, and myself, we are all involved in the ground implementation of most of the project activities. I thank all of you for hearing me out patiently, and the stage is open for questions. Thank you. Thank all of you for hearing me out patiently, and the stage is open for questions. Thank you.
Wonderful, Varun. Good to see you. And although we are discussing about probably the most endangered bird on definitely in this part of the world, we are happy that we have some positives, and we have clear indicators into what might work for bustards, and with a clear visual representation about which you already have answered few questions. So Suhail and few colleagues were asking about whether you clumped the data in your animations, and you've answered that.
Yeah.
Monica Kaushik wants to understand, you only tagged females, or do you have males, or do you expect males to be around as well?
So the patterns that are showed in the presentation are based on our tagged females, but the direct observations on males kind of support the same inferences. But we are hoping to tag males in the upcoming years, and hopefully we'll have some more robust insights coming soon.
Great. Bara wants to understand about their foraging ecology in the breeding season, and how does it vary across seasons?
Right, the movement patterns and the heat maps that I showed were essentially included the movement for foraging. Rather, most of the movement that was happening was for foraging and not otherwise.
So if I'll add and enhance that question, will it be like something that they get more protective for the areas and they select a different area once they're breeding?
Right.
It's not.
We think so. We think there are two things playing out. One is these birds probably have site fidelity. The birds that we have tagged have re-nested at the same place multiple times. At the same time, these breeding enclosures that I showed, prima facie have lot more arthropod biomass than the area outside. During the monsoons, when there are crops in the agricultural fields surrounding these areas, these are the resource-rich areas in the entire landscape. A habitat study is currently ongoing, and my colleague Indranil, who works on it, will at some point tell us more about it.
Suhail wants to just check about the sample size you used to build the demographic probabilities in the beginning of the presentation. Was it
right? This is based on 7 tagged birds. But apart from that, we had monitored many other eggs from non-tagged birds, and the results, the probabilities were more or less similar. So it's a combination of 7 tagged birds and a lot of eggs monitored through direct observation. And 7 birds in this case is around 5 to 10% of the population. So it's a fair sample size, I believe.
Thank you. I will take the last question in the interest of time while you can continue answering people on Discord.
Right.
So Dr. Kaushik wants to ask, what additional parameters are you going to obtain using the accelerometry data? Like, how is an accelerometer going to help?
Right. We are hoping to calibrate the accelerometer data to find out the exact to find out when the birds are foraging and when they're just moving around between foraging. So the main objective of that data is to tease apart the data between movement and foraging.
Okay. Fantastic, Varun. That was wonderful. I guess a lot of questions are going to pop up and we'll be very happy if you answer them. People can continue posting questions on Discord while we move to our next session, which is a panel discussion.